I'm Andrew Whittle. I'm a civil engineer, former head of the Department of Civil and Environmental Engineering. I've been at MIT a long time. I came as a graduate student. I've been here on the faculty just over 25 years. Most of what I do is deals with soil and rock as engineering materials. I mean, I deal with the challenges of big urban construction projects, for example, like the Big Dig in Boston. I've dealt with foundations of big offshore structures like the big oil rigs in the Gulf of Mexico. All big construction projects in urban areas are very heavily instrumented because of safety concerns to adjacent structures. So when they built the Big Dig, we were very concerned about the effects of the tunneling on adjacent buildings, and that was one of my primary areas of research. The importance of this really got driven home to me actually a little over 8 years ago when I was involved as an expert witness in a big failure that occurred ironically in Singapore, a big excavation that collapsed and killed a bunch of people. And one of the problems that arose out of that was there was lots of instrumentation, but the data weren't made available to engineers in an intelligible way so that people could do something with the data. So the result was they had the data, we could diagnose the failure, but looking back on it, that data should have been made available in a more practical ways for the project. So I've been very interested in how you get data into a timely format that's interpretable and usable. So to me, there's two separate elements. There's the data getting bit and there's the interpretation and use of the data. And in fact, I've been very interested in how to improve safety and security of those big construction projects ever since. And we're now in the second phase of Sensam, starting to work on instrumentation for big construction projects. Geotechnical engineering deals with the roles of the soils and rocks, the uncertainties they provide in construction. So yes, the context of the work I'm in is the local geology. So the geology of Boston is different to the geology of Taipei and Berlin and other cities I've worked in. We work very closely, I suppose the work I specialize in is most close to materials science. We're after all understanding how material properties affect what goes on in the system. We interact, of course, with the structural engineers who are doing most of the designs and have to deal with the uncertain loads from underground construction. And we deal with all folks involved in buildings on the impact on adjacent facilities. So it is at the intersection of those different disciplines. And that's one of the attractions. The other big attraction is the huge variety. I mean, there are no two cities where the geology is exactly the same, and there are no two cities where exactly the same solutions get adopted. So there are big differences between our experience in Boston, for example, versus Chicago, versus Taipei, versus Singapore. So that provides a very interesting environment for us to work. You know, one of the things that MIT has advantage of is the tremendous connection with industry and the opportunities that it presents for real-world projects. I've always been strongly motivated to solve real-world problems, and you really only get to do that and engage students in that process if you've got very good industry links. And I think that's one of the big strengths of MIT. I've been able to engage many years ago with the oil industry and some of their problems, and more recently these big urban construction projects. And the important thing is we've been able to train students through this process. So they've had opportunities to work in the field and engage in real-life projects, which I think have put a really tremendous context on their work. Have given them tremendous insights about the challenges of the real environment that they're working in. And I think that's absolutely critical when you're working on large infrastructure projects. You really can't do it in the corner of your office. You need to be out there in the field. So I think that kind of opportunity is very critical for the kind of work I do.